Assalamualaikum and good day everyone. My name is Nurul Atira binti Nuradin and today I would like to present about PN photodiode. So let's get started. What is photodiode? A photodiode is a semiconductor device that converts light into an electrical current. The device structure of PN junction consists of P and N semiconductor. Based on the figure here shows the symbol of photodiode, which is similar to the normal PN junction diode except that it contains arrows striking the diode. The arrows striking the diode represent light or photons. A photodiode has terminal which is cathode and anode. Photodiodes are also specially designed to operate in reverse bias condition. Reverse bias means that the P side of the photodiode is connected to the negative terminal of the battery and N side is connected to the positive terminal of the battery. Okay, so for the next slide, a normal PN junction diode allows a small amount of electric current which is under reverse bias condition. So to increase the electric current under reverse bias condition, we need to generate more minority carriers. The external reverse voltage applied to the PN junction diode will supply energy to the minority carriers but not increase the population of minority carriers. However, a small number of minority carriers generated due to external reverse bias voltage. As a result, no electric current flow due to discharge carriers. For example, the minority carriers generated in the P-type material experience a repulsive force from the external voltage and try to move towards N side. But before crossing the junction, the free electrons recombine with the holes within the same material. So, no electric current will flow. So, to overcome this problem, we need to apply external energy directly to the depletion region to generate more charge carriers. Okay, for next slide. When external light energy is supplied to the PN junction photodiode, the valence electrons in the depletion region will gain more energy. So, if the light energy, which is photon, we apply to the photodiode is greater than the band gap of semiconductor material itself, the valence electrons will gain enough energy and will break bonding with the parent atom. So, the valence electron, which breaks bonding with the parent atom, will become free electron, will move freely. Free electrons move freely from one place to another place by carrying the electric current. So when the valence electron leaves the valence shell, an empty space is created in the valence shell which valence electron left. So this empty space in the valence shell we call as hole. So both free electrons and holes are generated as pairs. The mechanism of generating electron-hole pair by using light energy we call as inner photoelectric effect. Okay, for next slide, the minority carriers in the depletion region will experience force because of depletion region electric field and also from external electric field. The free electrons in the depletion region will experience repulsive and also attractive force from negative and positive ions that present at the edge of depletion region on P side and N side. As a result, free electron will move towards N region. When free electron reach N region, they are attracted towards positive terminal battery. In the similar way, hole also move in all opposite direction. The strong depletion region in electric field and the external electric field will increase the drift velocity of the free electrons. Due to this high drift velocity, the minority carriers, which is free electrons and holes, will generated in the depletion region, will cross the PN junction before they recombine with atoms. As a result, the minority carrier current will also increases. Okay, For the other condition, which is when no light is applied to the reverse bias photodiode, it carries a small reverse current due to external voltage. This small electric current, under the absence of light, we call as dark current. In a photodiode, reverse current is independent of reverse bias voltage. Reverse current mostly depends on the light intensity. In photodiode, most of the electric current is carried by the charge carriers generated in the depletion region. Because of charge carriers in depletion region has high drift velocity and also low recombination rate, whereas the charge carriers in N side or P side has low drift velocity and high recombination rate. The electric current that generated in the photodiode due to the application of light we call as photocurrent. In this figure here, we can see VI characteristic curve of a photodiode. In this graph denoted the reverse current which is passing in the diode at a vertical axis and reverse bias voltage at the x-axis. The first curve on the graph defines that the dark current produced due to minority charge carriers without light. All other curves on the graph have equal distance among them due to the constant increment in current with the movement in luminous flux. In optic fiber relations, we already know that fiber optic communication itself using light signal to transfer data from one end to another. Once data has been transmitted across fiber optic cable, it is necessary for it to be received and converted into electrical signals for be processed. Within the fiber optic receiver, the photodetector is the key element. A variety of semiconductor photodetector may be used as fiber optic receiver. They are normally semiconductor devices and also a form of photodiode. A variety of diodes may be used in fiber optic receiver, which is PN photodiode, PIN photodiode, or an avalanche photodiodes. One of the key to the performance of the overall fiber optic receiver, which is the photodiode itself. The response time of the diodes governs the speed of the data that can be recovered. The standard depletion region is 1 to 3 micrometer is optimized for the efficient detection of light at certain wavelength. So that's all from me, and thank you for your attention.